trigonometric functions then. When you have a right triangle and you define your angle theta, you have three sides to the triangle, and of course, you know, the hypotenuse is always the same side. It'll never change no matter what angle you're looking at. So in reference to theta, you have two sides. One is the opposite, one is the adjacent. And if you recall, sine of theta is just the ratio of the two sides of the triangle, opposite over hypotenuse. So that's all these trigonometric functions are, is you have a right triangle, you now take any two of the three sides and you compare their sizes. So for example, if we're taking, you know, the opposite side on the hypotenuse, and if this is 3 and if this is 5, you're just doing a comparison, 3 to 5 or 2 to 6 or 4 to 8, all right? In the case of the adjacent, if this is 4 and you compare the adjacent to the hypotenuse, the comparison is just 4 over 5, 4 to 5. And instead of saying every single time the comparison of the adjacent side to the hypotenuse, we just say the cosine of theta, and that's code for the comparison of the adjacent side of the hypotenuse. So if you just step back and take a look at the way a right triangle is constructed, what's the longest side always? Hypotenuse. The hypotenuse. So now if you compare an opposite to a hypotenuse, the opposite, because it's a leg, it's always going to be smaller, right? So that ratio is always going to be less than 1. Okay? That means the sine and the cosine are always less than 1. Similarly, now we have the cosecant. It's just the same ratio but flipped over. Now you have the hypotenuse over the opposite. So if I flip this over and do 5 over 3, it's always going to be greater than 1. So these two are always greater than 1. Now, the tangent and the cotangent both deal with the two legs. And there are never any restrictions to which one of the legs is supposed to be bigger. That means that the tangent and the cotangent can either be greater than 1, less than 1, equal to 1. There are no restrictions. Okay? So these two are either less than, greater than, or equal to 1. Okay? So you should always know that. So if you're finding the sine of an angle and you get 2 point something, you know that you've done something wrong. Okay? Now, we have some further definitions. So we said that the cosecant is just the sine flipped over. Well, that just means that it's 1 over sine of theta. And similarly, secant can be written as 1 over cosine. Cotangent is 1 over sine. And if 1 over tangent. And if we go a step further, okay, if I take the sine of theta and divide by the cosine of theta, well, magically, that's the same as tangent of theta. And if you take the reciprocal, then cosine over sine is cotangent. None of this should be new to you, okay? I'm just reminding you. All right, so here, it says to find the values of the 6 trig functions. Here is theta, and you always define your sides in reference to theta, meaning this is now the opposite side and this is the adjacent side. That means that the sine of theta is opposite over hypotenuse, 33 over 65. I'm going to leave them as simplified fractions for now. Cosine of theta is then 56 over 65. Tangent of theta is 33 over 56. And if you just explore for a tiny little fraction, if you take sine of theta over cosine of theta, what is that? That's 33 over 65 divided by 33 over, did I? Oh, sorry, 56 over 65. Right? The 65s cancel, and you just get 33 over 56, which is tangent. So sine over cosine is tangent because they're both being divided by the same number. All right, now, the cosecant of theta, you no longer need to be doing any work. The cosecant of theta is just 65 over 33. Secant of theta is 65 over 56. Cotangent of theta, 56 over 33. Okay? Now, these are the values in simplified fractions. If you want to put them in decimals, all you would have to do is divide 33 by 65. The condition is that you always need 4 decimal places. Yes. You don't have to go to sig figs. Okay, so you can just leave it as 0.75 or 0.5. However, if it's a non-ending decimals, you need 4 decimal places. Okay? So if it's 0.5, you don't have to do 0.5000. Okay? All right. All right, using one trig value to find the other. So here what I have is the sine of theta, and I need to find all of the rest. Okay? What I do is you first draw a triangle. You draw the triangle here. This is theta. Now, I'm given sine of theta, and I know that sine of theta is opposite over hypotenuse, right? That means the opposite side is 1. The hypotenuse is √3. And here you have a missing side, x. Well, I can easily find x. Oh, 1 over 3. So next, to find x, 1 plus x squared is equal to 9. X is 2 radical 2. All right. Once you have all 3 sides, you can then go and find your other trig functions. We already have sine. Cosine of theta is 2√2 over 3. Tangent of theta is 1 over 2√2, which is what? √2 over 4. Okay? You have to rationalize. Cosecant of theta is 3 over 1. Secant of theta, 3 over 2√2, which is 3√2 over 4. Cotangent of theta, it's easier to take the reciprocal of the second to the last step, so it's 2√2. So, right triangles can have a variety of angles, but we know that there are 2 right triangles which are called special triangles because they are constructed of special angles. One is the 30, 60, 90 triangle, and the other one is the 45, 45, 90 triangle. The 30, 60, 90 triangle has angles of 3 different sizes. All right, there is a small angle, which is the 30 degrees. There is a medium angle, which is the 60, and then there is the large angle. And we know that in triangles, the small angle always faces the smallest side. The medium angle always faces the medium side, and the large angle always faces the large side. Okay, now, In the 30, 60, 90 triangle, the relationships of the sides are always the same. We always call the small angle x, okay? And now you have the medium and the large. So if you have x for the small, the large is always 2 times x, okay? So the medium one is somewhere in between 1 times x and 2 times x. What's the square root of 3 equal to? What's the square root of 3 equal to? What is root 3? What is, huh? It's 1.7, right? So if I multiply the x by root 3, it's like 1.7 times x. So you see how it's in between 1x and 2x? That's the middle side, okay? Well, it's not exactly in the middle. It's just the it's, you know, you have small, medium, large. You have a small side, one that's less than the larger one. Okay, so now, because no matter what size of the triangle, the ratios of the sides are all the same, you can then always in your head figure out what the ratio is of the opposite to the adjacent side of 30 degrees, right? So if you take 30 degrees, what's the opposite side to 30? It's always x. What's the adjacent? It's always root 3 times x. So it's always 1 over 3. Okay? So the tangent of 30 is always 1 over root 3, which is root 3 over 3. Okay? In the case of the 45, 45, 90, we know that if you have two angles that are congruent, that's a what type of triangle? Isosceles, meaning it's got two congruent sides. So the two sides that are congruent are the legs. Those are x and x. And this is the hypotenuse. It has to be bigger. It's root 2. Now, most of the time, the x just gets in the way. So we don't write the x most of the time. Most of the time, it's just 1, 1, radical 2. Or in the case of the other one, it's just, this is the 30 degrees, so it's 1, radical 3, 2. Because the x always cancels out anyway. Okay? So, if we then have, okay, so here is a chart, okay, just to give you an idea, right? And I know you've seen this a million times. I do not want you to sit there and memorize the chart because afterwards we're going to learn how to do it with the unit circle, okay? So, here, I'm going to do this one first, sine of 45. So, sine of 45 means this is the opposite over the hypotenuse. And remember we said for the sine, the legs are always equal to 1. And the hypotenuse is always root 2 times that. So it's root 2 over 2. All right? If you get stuck, all you have to do is draw the triangle. You can even visualize the triangle. Here I want cosecant of 30. Cosecant is like sine. So it's hypotenuse over what?
Opposite.
Opposite. Now, in a 30, 60, 90 triangle, hypotenuse is always how big? 2. And now, this is the 30 degree. 30 degree is the small angle. That means it faces the small side. The small side is always just 1. So it's 2. Okay? Here's how I want you to do it. I want you to visualize it, reason it out. Now, what's the important part? In example 3, we're still there. What's the most important part, do you think, in the directions for example number 3? There you go. Without using a calculator. Okay? You guys are smart. Okay? It'll be, that means like no calculators. There'll, not even scientific. So it won't be the whole thing. There may be 2 parts. But definitely these are on the non-calculator part, okay? Because let me tell you something. You cannot be sitting in any calculus class and still be, you know, slow on tangent of pi over 3 or cosecant of 2 pi over 6 or whatever, okay? All right, so here we're just going to insert these symbols. What's tangent of 60? Okay, so here's how I do this. Tangent of 60 is the opposite over the adjacent. 60 is the big angle, faces the biggest side. So that's root 3 over the adjacent, which is the smaller side, 1. Now, cotangent of 30. 30 faces the small side, so this is going to be what? Rat 3 over 1 again. Okay, so these are equal. Now again, cosine of 30. Now you're more than welcome, if this is on the test, you're more than welcome to sketch a triangle. Of course, why not? Okay, done. And now, okay, cosine of 30, radical 3 over 2. Secant of 45. Well, for the 45s, I know that it's always 1, 1, radical 2. Secant is like cosine, hypotenuse over adjacent. Okay, so which one's bigger here? Radical 2 is bigger because this is being divided by 2, so it's this way. Yes?
For y, cotangent and tangent equal the same.
It's not cotangent and tangent that are equal. It's cotangent of 30 and tangent of 60. And that's actually an identity. It's a cofunction identity, which we'll talk about in section 5.1. Okay, another one. Without using your calculator, this is actually like straight out of a lower geometry, right? It's not even... So we know that this is an isosceles triangle. The sides are equal to each other. You know, and the only excitement here is that it's a quadratic equation. Boo-hoo, right? So x squared minus 6x plus 9. X minus 3 squared. So x is equal to 3. And as long as it's positive, we're good to go. So this guy here in example 6 is swimming in a competition. And here is one where you would need your calculator. Find the distance the competitor must swim in order to reach the shore. So here's what we need to find: x. We're given an angle. We have an opposite side and an adjacent side. So if you just translate the entire world into triangles, you will see how many different applications of this stuff there are. Okay? So this is the tangent. You always ask yourself, okay, opposite and adjacent is what ratio? It's the tangent. Tangent of an angle always equals x over 75. Okay? Multiply by 75 on both sides. So 75 times tangent of 48 is equal to x. So here and now, take out your calculators. Okay, so make sure that you are in degree mode. All right, so what you want to do is press the mode button, which is right next to the second button. And the second the second option there gives you the choice between radian and degree. So 75 tangent of 48. It's 83.3.
How do I change it to...
Okay.
Oh, I did 42, not 48.
Okay. Mode button is here. Second one next to the second sign. And then if you go in there, the second option is the choice between the two. So we can go to 1 decimal place if it hasn't specified. If units are specified in the problem, your answer must include units because there will be points allocated to units. So that one was in feet. Now, in that problem, we were looking for a side, right? That's what was unknown. It was a side. Now, if you have to find an angle, then you have to use the inverse trig functions, right? And if you remember, this is inverse sine. So on your calculator buttons, right, if you have sine of x, the shift option, right, is sine inverse. All right, a direct application of that is angle of elevation and angle of depression. All right, so suppose you're standing somewhere and you see an airplane approaching you from the sky, okay? Your line of sight is at a certain horizontal level, and the angle that your line of sight makes with the airplane is your angle of elevation. Okay, if you're looking up, it's an angle of elevation. Now, if you visualize the pilot, he's looking down at you at some distance far away from him. He has an angle of depression. Okay, that's that angle there. Okay? Now, so look at this one. Fantastic problem. The angle of elevation from a car to the top of the apartment building is 48 degrees. If the angle of elevation from another car, there should be another word there, that is 22 feet directly in front of the first car is 64, how tall is the building? So what I want is this value of y. Okay? Now, here's how we're going to do this. There are two triangles here. In the first triangle, we're going to focus on this one, the inner triangle. Now, if we only knew this distance here, okay, well, you know what? We could just call that distance x. So now, that inner triangle tells me that tangent of 64 is equal to y over x. This is the inner triangle. Now, the outer triangle has another angle, tangent of 48. The opposite side to 48 is y, and what's the adjacent side? X plus 22. So, yeah, so here, in the first case, if we solve this for y, it's x times tangent of 64 is equal to y. And here, x plus 22 times tangent of 48 is equal to y. Since both of those equal y, then we can set them equal to each other. So I can set this equal to that. So I get x tangent of 64 equals to x plus 22 tangent of 48. And now it's similar to what we did with the ln, so you distribute the tangent of 48. Equals x tangent of 48 plus 22 tangent of 48. I want to collect the x's. Tangent of 64 minus x tangent of 48 equals to 22 tangent of 4, the 8. Okay? Take out an x. Tangent of 64 minus tangent of 48 equals 22 tangent of 48. I do not want to see you guys plugging in these tangents and working with decimals. Okay? We are going to plug it in at the very, very end. So x is now 22 tangent of 48 over tangent of 64 minus tangent of 48. All right? And we plug that in. So 22 tangent of 48 divided by...
Wait, no, but that's not going to the building, that's going to the tree.
Yes, it is. Well, actually, you know what? Let's save that step. So y, I don't want to put in a decimal later. So y is equal to x times tangent of 64, which is x times tangent of 64. At the end of the day, y is about 53 feet. Right?
Wait, what, how did you?
Well, from here, right? Okay? We go here. So basically, it's two equations with two unknowns with trig functions, which, you know, we haven't done before, but why not? It's totally doable. Okay? And this is it. This is why this is such a wonderful, wonderful course. So if we want to solve a triangle, that's just code for find everything that's missing. So you know that there are 3 angles and 3 sides to a triangle. That's 6 total elements. You're usually going to be given 3 of those, and you need to find the other 3. Okay? All right, so right, so in this case, the angle is easy. We're going to do 180 minus 41.4. How much? 48.6. And now, to find the sides, I always like to use the information that they gave me in the problem.
Yeah, how is that 40.6?
Oh, sorry, it's 90 minus that. Okay, so to find h, here's my angle, and I'm given the hypotenuse. It's adjacent and hypotenuse, meaning it's cosine. So cosine of 41.4 equals h over 28. That means 28 cosine of 41.4 equals h, which means it's 21. And f is the sine, right? So sine of 41.4 equals h over 28, f over 28. So f is 28 sine 41.4. Okay, so wait a minute, how much was this? Okay, technically, you can do the Pythagorean theorem. I would advise against it because of 2 reasons. A, this is simpler math as opposed to like squaring and adding and subtracting and taking the square root. And B, as I said earlier, I always, if I can, like to use only the information that they gave me, because what if I found h but I made a mistake? Then if I use that to find another side, then that's going to be wrong as well. Okay? This way, at least I minimize that part of the mistake. But technically, any way is fine. Okay? So this is section 1. This homework will be due on Monday. We do. During the day. I'm also going to cover section 2. I'm going to start on 2 and see how much I can get through. So section 2 is about angles. So how to create an angle? You create an angle by combining 2 rays. Okay, so look. Here we have a ray, and here we have another ray. All right? You remember ray has an end point. If you join two rays at their end points, you automatically create an angle. The end point where the two joined is called the vertex. Okay? Now, you generally start with an angle of a ray that has no angle, and then if you rotate a second ray upwards, then you start producing your angle. So this side is called the initial side because that's where you start producing your angle, and the final location is then called the terminal side. Now, I can place an angle anywhere in the universe. However, in that one specific case where the angle is at the origin, so the vertex is at the origin, that's called an angle in standard position. Okay? Now, measuring an angle starts from the x-axis. If it's in standard position, it starts from the x-axis, and for a positive measure, we go counterclockwise against the rotation of the clock. For a negative angle, we go clockwise. Okay? Now, units. How do we measure an angle? Well, we measure an angle using units of degree. That's one of the units for an angle. And to just visualize what that is if you have a circle, so suppose you have a perfectly circular pizza, and if you were able to cut it into 360 slices, each one of those slices would represent a 1 degree angle. All right? So if you could slice a circle into 360 parts, then each one of them is a degree, meaning it's 360 degrees around the circle. Okay? And here are the most common angles, right? And these are, surprise, surprise, the special angles that we talked about. 30 degrees, 60 degrees, and 45 degrees. And then their equivalents on the other side. I mean, we're going to do this at such great length. So one unit is the degree. Another one is the radian, abbreviated as RAD. And what a radian is this. So suppose you form an angle inside a circle. That angle automatically cuts a portion of the circle. That portion of the circle which it cuts is called the intercepted arc. Okay? Now, suppose you can measure that intercepted arc with a piece of string and then, straighten out the string and measure it on a ruler. If that intercepted arc has the same measure as the radius of the circle, then that means you have an angle of 1 radian. Okay? So an angle of 1 radian means the radius and this intercepted arc have the same length. That's 1 radian. And because, what's a radian? It's that length over that length, that many centimeters over that many centimeters. The centimeters go away. So the radian is without units. It's unitless. Okay? That's why most of the time when we say, okay, this angle is equal to like 3 pi over 2, we don't put RAD, we don't put radian, because it's just a unitless unit. Okay? All right, now, you guys remember this from geometry, right? This angle theta is equal to S over R. So if you take this length over that length, that's theta. So we're gonna use this in a little bit. Okay? All right, so look at how fun this is. All right, so if you go around a circle, you've covered its circumference. And you've gone around a distance of 2 pi r. Is that right? Yeah. Now, we just said theta equals S over R, right? Yes. S is the distance around the circle, which is 2 pi r, right? So theta is 2 pi r over r. What happens to the... They cancel. So what's the full theta in a circle always?
2 pi.
2 pi. That's where it comes from.
That makes sense.
Yes, it does. The Greeks were very sensible people. And pi is...
Well, they did like...
Therefore, theta around a full circle is 2 pi. I'm trying to highlight that very important part, but it won't let me. Okay? This leads to the realization that Idan just came to, that 360 is 2 pi. That means 180 is pi. That means 90 is pi over 2. That means 30 is pi over 6, and so on and so forth. And that's where it comes from. And this is how we can convert. The Greeks were smart people, okay? They pretty much laid out the basics of all the math that we cover today, and science. Okay? So Archimedes, Pythagoras, right? Copernicus, Pythagoras right there, yes. All right, so speaking of science and chemistry, conversion of units, right? Okay, here we go. We're converting 135 degrees to radian. So that means I have 135 degrees times a conversion factor. The conversion factor is 1 pi to 180. If the degrees are on top here, they go on the bottom here, and pi goes on top. That means the degrees will cancel, leaving you with radian. So this is 135 over 180 pi, and we never leave it as that. What's the simplified fraction? 3/4 of a pi, which is 3 pi over 4. Negative 30 degrees times pi over 180, negative pi over 6. And everybody knows that, right? That 30 degrees is pi over 6? Of course we do. Because pi is 180, and if we divide 180 by 6, we get 30. Okay? All right. Now we're going to go the other way. So times 180 over pi, because if pi is up there, it needs to be down here. 180 divided by 3 is 60, so this is how much?
No, it's 180.
2 times 180 divided by 3, what is that?
180 divided by 3 is 60
90.
times...
Times 2, 120. 120.
120, yeah.
Times 180 over pi. This is negative 135 degrees.
Negative 135 or
Negative. More fun with radian. So we know that pi is 3.14. That means pi over 2 is 1.57. And how do we know that pi is 3.14? Because pi, as the 22 over 7, as the Greeks figured out, pi is the circumference divided by the diameter. So if you take any, so the Greeks took every single circle in the world and they said, let's divide the circumference by the diameter, because you know what, there wasn't much to do then other than making sundials. So they would divide the circumference by the diameter, the circumference by the diameter. Every single time they would get 22 over 7. So that 22 over 7 became known as pi. Okay? 22 over 7 is 3.14. That's why pi is 3.14. So 2 pi is 6.28. Da-da-da-da-da. Okay? I'm hoping you know that pi is 3.14. And 2 pi is 6.28.
How did they get so many different digits of pi?
That's pi over 2. That's all the same.
22 over 7 isn't like exactly pi.
No, it's not.
Well, because your calculator doesn't have the capability to give you everything that's in the back there. You see that chart in the back?
But it's not even 3.141. It's 3.142.
We'll do rounding.
You're rounding. You've told your calculator to round to 4 decimal places. So that's what it's doing.
It's just 3.142857123.
It doesn't matter, it's still 3.1.
Okay.
Is it approximation?
So if you get a circle, and if you want to compare radians to degrees in a circle, one radian, so this is how they look, right? So you have 360 degrees, but just 6 and a little bit radian. Okay? That's just extra stuff. Okay. All right, so
How is it that it's a little bit up? If it's never be equal size?
Because it's 2 pi.
So I'm questioning the brainwashing that's been going through us this last 5 years.
These three signs are equal.
Pi. Oh, that's 1 pi.
Except
no,
for
they're
the
not. Pi is 3.14. It's 3.14 radian. That's just 3 radian. Okay. Let's draw a 30-degree angle. That's, I'm just estimating, 30-degree angle. Okay? Now let's draw a 390-degree angle. So here's 360. I need to go 30 more. It's the same. Okay? The same meaning the terminal sides of the two angles coincide. When the terminal sides coincide, we call them coterminal angles. Right. So to find coterminal angles, yes.
No, 2 pi. Just a multiple of 360.
Okay, so here's what you do. You add or subtract multiples of 360 or 2 pi. So it's either 2 pi times n or 360 times n. Okay? All right, so how would I find coterminal angles of 80? So first it says identify all angles which are coterminal. So we say 80 plus 360n. Okay? And it's also 80 minus 360n. And then it says to find and draw one positive and one negative coterminal angle. So positive is 80 plus 360. Huh? Huh? What did you say? I couldn't even hear you. It wasn't.
I was thinking it.
I couldn't hear you. I'm sorry.
But nobody heard it, so you gotta take off.
I heard it, but I didn't get it.
Yeah. Is it a derivative acceptance?
Okay, so to draw this, right, so here's how we denote this. 440. Okay, I want to see that spiral arrow, and then negative 280. It gets so confusing to follow spirals, you know what I mean? Okay, so negative pi over 4, it's going to be negative pi over 4 plus or minus 2 pi n. So for the positive one, It's negative pi over 4 plus 2 pi, which is what? 7 pi over 4. And for the negative,
These types of problems we have to like the fractions.
okay, so we learn adding fractions in when you're 2.5 feet tall.
2.5. No.
Okay? All right, so what does S equal to?
Alright, stop.
Okay, what does S equal to? R theta. All right? The big, huge deal is theta is measured in radians. So in this problem, find the length of an intercepted arc in a circle with a given angle. So the 125 needs to be converted. Okay? What's 125 over 180? 25 over 36. So now, if S is equal to R theta, literally these are just plugging and chugging, and you can find R or theta or S, and it's the same. So it's 7 centimeters times 25 pi over 36. And
No, 1/7. Yeah.
Wait, the answer of the 7 cm times that is S.
huh?
The answer of that is S, right?
Yes, the answer of this is S. How much? 15.27. So it'll specify on the test. Yeah. It's what you're given. The angle that you're given in the problem, it's the central angle. Right? It's a central angle. And this is R, 7 centimeters. And what you're looking for is the intercepted arc. Okay? Yeah. Now here, A equals half R squared theta. This is the area of this sector. Okay, so area of a sector is that, and it's exactly half times base times height, but throw in an R and a theta, and you know that's exactly what it is. So 60 degrees is the same as pi over 3. So A is half times 64 times pi over 3. It's 32 pi over 3, which is 33.5 square feet. Okay? Now, here's what I'm going to do with homework. It's where it comes from. Okay, so listen, here's what I'm going to do with homework. I'm going to split this homework up into 2, and the first part will be due for Monday, because next time I will teach the continuation of this and 3, okay? Because I have to do this because I'm behind 1 period. This way we'll catch up so you can actually take the test before the final. The other class already finished section 3. Because they took their test a while. This is still the repercussion of the holidays. They're A period. A and H are right, but still they're past section 3. Okay? This way you will now end at the same place. So for this homework, I would like you to do,
Next one after this is due Wednesday, right?
Should we just go up to 35?
no. Okay, so here's what I want you to do. 11 to 19 odd, 23, 29. There's a chunk in the middle that I didn't do, which is odd. And then 43, 45, 51. Okay? And the other half you will do 4. So these are due Monday.
And we have to do 4.1.
Did you take off over